Okay, student. So today we are going to start a new topic. A dipole placed in a uniform magnetic field. The chapter number 5. Okay. So the topic is what? The topic is a dipole. A dipole placed in a uniform what? Magnetic field. In a uniform magnetic field. So today our topic is a dipole placed in a uniform magnetic field. First, the magnetic field. What is the magnetic field? When a charged particle is moving, okay, when a charged particle is moving, then it forms a magnetic field. When a charged particle is moving, then definitely it forms a magnetic field. And next, what? A dipole. Dipole means what? Dipole means two. So there are two charges. There are two charges. One charge is positive and one charge is negative. The magnitude of the two charges are equal. Okay, the charges are opposite direction, one positive and one negative, and the magnitude of these charges are equal. So these two charges placed in a uniform magnetic field. So uniform magnetic field means what? We draw a this is a uniform magnetic field. The direction of the field are equal. Okay, the direction are equal and the gap is equal. Okay, so this is a uniform magnetic field. Uniform magnetic field is denoted by B. Okay. So here we place two charged particles. Okay? One charge minus Q and one charge plus Q. Okay. So this is the midpoint of this dipole. This is the midpoint. Okay. The distance between these two charges is what? Twice. Okay. The distance between the two charges is what? Twice. So now one thing, the dipole, the distance twice, and either one of the charge means it may be positive or it may be negative. This is twice AQ. It is called what? It is called dipole moment. So dipole moment denoted by what? P. It is a vector coordinate. Okay. In the previous class, we all of you just know this. Now start the topic. Okay. A dipole placed in a uniform magnetic field. First, we draw a uniform magnetic field. Look at this. This is what? This is the uniform. This is a uniform magnetic field. Okay. The uniform magnetic field is denoted by what? It is P. So in this uniform magnetic field, we place two charged particles. In this uniform magnetic field, we place two charged particles. One charge is minus Q and what? And another charge is plus Q. Okay, one charge is plus Q and one charge is minus Q. And assume this dipole makes an angle theta. This dipole makes an angle theta with the uniform magnetic field. Okay, so automatically there will be two. Automatically there will be two pole, one pole south pole and one pole is here, but and one pole is north pole. So, and this uniform magnetic field has the dipole moment. And in look at this one thing. So here, this is what? This is the center point. O is denoted. O is the center point, and the total length of this dipole is what? Twice it. Therefore, the dipole moment. Therefore, dipole moment is what? Twice a q. So twice a q is called the dipole moment. Now, now start again. Let a magnetic dipole let a magnetic dipole of what? Dipole moment of dipole moment of let a magnetic dipole of dipole moment what? Dipole moment M. Place, look at this. Place at where? Place in a uniform. Place a uniform magnetic. Place a uniform magnetic field. Place a uniform magnetic field where, where moment of inertia what? Moment of inertia is I. Where moment of inertia I. So this dipole, look at this. So this dipole in a diagram makes an angle. So this dipole makes an angle theta with the magnetic field magnetic field is what? Magnetic field is B. So with the magnetic field is B. Okay. So this dipole, look at this diagram. This diagram makes an angle theta. With the dipole. Okay. Where, look at this, the moment of inertia is I. So this where there is a moment of inertia, then it forms a magnetic torque. Okay. Now look at this. Now let at any instant theta the magnetic torque let at any instant theta the magnetic torque. So what is the formula of the magnetic torque? In the previous class we know this. The magnetic torque denoted by tau. This symbol is called tau. So it is a vector quantity. So tau is what? Tau is equal to m vector cross what? M vector cross b vector. Okay. If we remove this sign, then this is what will be? This is mb sine of theta. Okay. Mb sine of theta. Let tau rest be the restoring torque. Let tau rest be the restoring torque. So at equilibrium, we have a formula equilibrium. We know this. So tau rest. So tau rest is equal to so tau. Okay. So tau rest is equal to minus tau. So minus, what minus denote? So that negative sign indicate, this negative sign indicate that restoring torque, the restoring torque oppose the deflecting torque. The negative sign indicate that restoring torque. The negative sign indicate the negative, there is a minus sign. So what the minus sign denote? The minus sign indicate, okay? The minus sign indicate the restoring torque. Restoring torque which oppose the deflating torque. Which oppose the what? The deflating torque. So so ये जो tau rest है, tau rest का फॉर्मूला क्या होगा? Look at this now. Okay. So tau rest. Look at this now. So this tau rest denotes what? So this tau rest इसका फॉर्मूला क्या है? I into alpha. Okay. I into alpha. So what this two sign mean? So here I denote the moment of inertia and alpha denotes what? Alpha denote the angular acceleration. Okay. So here tau rest is equal to I into alpha. I denote the moment of inertia and alpha denote the angular acceleration. And is equal to minus tau formula क्या है? Just mb sine of theta. Okay, where theta is the angle, no, in this diagram. Here alpha denote the angular acceleration. So we can write therefore I alpha denote what? D square theta by dt square. Okay, is equal to minus mb sine of theta. Okay. This implies we can write this in the form d square theta by dt square is equal to this is mb by I. mb by I, what? This is mb by I sine of theta. mb by I sine of theta. Okay, the angle theta is very small. The angle theta is very small. Therefore, we can write it in the form d square theta by dt square is equal to what? This is mb by I is equal to what? Theta. Okay. we can write, since sine of theta is almost equal to theta. The angle sin theta is very small, so we can write sin theta is almost equal to theta. So it is, therefore we can write, so d square theta by dt square plus what? mb by I theta is equal to 0. So this gives a equation of a formula. Okay, this is the equation 1. So we are marking at equation 1. Okay. The equation 1 is the standard equation. The equation 1 is the standard equation of simple harmonic motion. Okay. In the first class we know this the simple harmonic motion. Okay. So the equation 1 is the standard equation. It is the standard equation of the simple harmonic motion. Okay. Now, therefore, we can write this in the form as what? This d square theta by d. Okay, so wait, please. This is d square theta by dt square plus here mb by I. The mb by I we can write as omega. This is the formula of omega square theta. Omega square theta equal to 0. This is a symbol omega. What does omega mean? The omega means angular frequency. Okay? The omega means angular frequency. So we have, since where we can write as where omega square is equal to what? mb by I. Or we can write this also in the form omega is equal to what? This is mb divided by I. Okay? So the form of omega is mb by I. Okay? So we have also a formula omega. Okay? Now we can write this in the form as look at this. So omega इसका फॉर्मूला क्या है जी? Twice pi by t. Here t denote what? T denote the time period. Okay. So twice pi by t is equal to what? This is equal to this is mb by I. This implies we can write this 1 by t is equal to 1 by twice pi. 1 by twice pi mb by I. 1 by twice pi mb by I. So here t is the time period. So 1 by t denote what? 1 by t denote the the frequency. Okay. So 1 by t denote the frequency. Frequency what? Mu. Frequency what is mu is equal to this is 1 by twice pi root over what? mb by I. Okay. One formula. So it is the the equation of frequency is what? Formula 1 by twice pi root over mb by I. Okay. Again, we know that since the torque acting on the dipole, formula क्या था? Tau is equal to what? mb sine of theta. So there is a small work done. Okay, now look at this. Now, okay. The torque acting since since the torque acting since the torque acting on the dipole since the torque acting on the dipole, what tau is equal to what? This is tau is equal to okay mb sin theta. So there is a small work done. So there is a small work done. The small work done in the deflecting the angle since the small work done for deflating the small work done since the small work done for deflating the angle, okay, for deflating the angle d theta. Since the work done is small, so therefore the angle deflating is also small. So that the small for the small work done, the deflating the angle d theta. So therefore the work done. Therefore the work done what? dw is equal to, so इसका फॉर्मूला क्या होगा? So work done means force into displacement. Okay, so displacement is what? This is tau theta. So in this equation the work done is what? This is dw is equal tau into d theta. Okay, so from this we can write therefore the total work done. So we have to integrate both parts. Okay, tau into theta. क्या मिलेगा हमको? Integration dw is equal to this is w. Okay. So integration tau का फॉर्मूला क्या है? mb sin theta. mb sin theta into okay. Okay. Now this implies what? The w here mb is a constant. mb is out. So integration sin of theta. So integration sin theta means what? Integration sin theta means this is minus cos of theta. Integration sin theta is equal to what? This is the minus cos theta. So we can write it in the form minus m vector dot what? This is b vector. Therefore the work done is what? Work done w is equal to this is minus m vector dot b. So this work done is stored in the form of potential energy. Okay, so look at this. Okay, so okay, so this work done is stored. Okay, so this work done is stored in the form of in the form of what? In the form of potential energy. So this work done is stored in the form of potential energy. So potential energy is denoted by U. Okay. So therefore we can write potential energy U. Okay. Potential energy. So we can write potential energy. This therefore we can write U is equal to what? Minus M vector dot product, which is P vector. Okay. So this is the required our expression. So this is the required expression. Now there are also two conditions applies the angle theta. When the angle theta will be 0, when the angle theta will be 180 degree. You can also write that number 1. If the angle theta equal to 0 or 180 degree, if the angle theta will be 0 or 180 degree, then what is the value of the potential energy U? Since the angle sine, we know that sine 0, 0 and sine 180 is also 0. Okay. So when the angle theta will be 0 or theta will be 180 degree, then automatically what? Then automatically the potential energy U equal to or will be 0. Okay. The potential, okay, one thing is sorry. When theta equal to 0, then therefore tau equal to 0. Okay. So when if theta equal to 0 or theta equal to what? 180 degree, then definitely torque will be 0. So this is our required expression. So if you have any doubt, if you have any question, if you have any advice, then please give me in the comment box. You can also please subscribe to my channel and share. Okay, thank you.